Hey, so in this video, I'm going to explain the payload, the MSFvenom, the multi-handler web shell. And in the previous video, we have talked about the reverse shell versus bind shell, and we'll just kind of do the overview of these things. These are the tools that actually help us to get the reverse shell. So it's not very we will not go in very detail into these, but let me start from the payload. Once we cover that, I will just come to these and just give you overview. Okay, so let's start from the payload. A payload is basically just a code that execute when execute on the target machine, it creates a shell back to you. You have like specified your IP, your machine IP and the port. So when you are that get executed, the payload get executed, it gives you the shell back to you. So there are multiple methods for that. One is the FIFO FIFO1 method. So normally the Netcat tool has a flag called the -e, which mean execute, but because of the security reason, it is not included in the modern Linux system. So that is the easiest way to get the shell, but since it is not available or not included because of the security reason, so we might don't have this, and we will have to use other methods like Netcat reverse shell with no e flag, without the e flag, without the execute flag, right? So this is one of the method. MKFIFO, this right here means it's like creating a tube between you and the attacker, between the target and the attacker machine. So think of it like two computers. These are two computers, and this is the kind of the tube. And this right here, this guy is the Netcat reads input from the pipe. Whatever comes back from the SH, the shell, right? So this is the think of it like this is my machine, a hacker machine, and this is the user machine that I want to hack or do stuff on. So I will send command from this and it will goes through the tube to this machine. So this right here will read those command that I execute here on my machine, and it will flow through the tube, right? And this right here will receive the, this will read the input that we just type over here on our hacker or attacker machine, and this guy will receive the command whatever we executed, whatever we type, and this will execute that. So once it get executed, whatever result it gets, it will send it to sends the sh output back into the pipe. So this guy, this compromised machine, will send the output back to the tube, so that we can get it on our attacker machine, right? And then it will, this guy will clean it up, so there will no any trace left, so that even if someone wants to check what happened, they won't be able to see, because we have just cleared with this. So this is the one way we can get the reverse shell using the Netcat. Another is the PowerShell reverse shell. This is the command that will help us to give us the reverse shell. Here is some important stuff in a TCP client, where we specify our attacker machine, where we will be controlling the machine from the IP of that and the port we want to specify. Then the get stream is where is the get stream? Yeah, this function right here, what this gonna do is gets the data stream from that connection, the pipe you can read through, and then the stream dot read incoming bytes, our command that we execute from our attacker machine. This PowerShell on the compromised machine will read the output that we send from here, and then it will execute it using this execute the receive command as PowerShell. This is run as part, and then stream.write is like sending back the output to our attacker machine, right? As I said, we will specify our IP and port in the PowerShell over here, PowerShell reverse shell. Now we need to move to the MSFvenom. What MSFvenom is, this right here, this transition you see. Writing payload by hand is fine for simple cases, but what about complex one? What if you need a payload for a specific operating system? Like, what if a payload for a specific operating system and architecture in a specific file format with antivirus evasion in mind? You will be writing for hours. So that's why MSFvenom exists. It's It's a factory that generates any payload you need in seconds. So it is something that generates payload. MSFvenom is a command line tool that generates. It is actually part of the Metasploit, but it is a separate tool that can also be used separately from using the CLI, right? To generate the payloads, you describe what you want, the target operating system, the architecture, type of shell we want, and the output format, and it creates a code for us. You upload the code to the target and we execute it, or the user execute the code on the target machine, and we get the shell. So these are some basic commands of the MSFvenom. So this is the whole structure of this. This is a real example. MSFvenom, this is the tool. With -v we specify the payload, what kind of shell code to generate. This follows the naming convention below. Okay, so these are, I guess, that these are the things. Output format, one is exe, other are like php, pys, px, var, and raw. So with the -p we specify what kind of shell code to generate, right? And then with the -o, what this guy is, we just, this is the output file name, and here we specify our target machine, the machine we'll be using to get the connection on, and this is its IP, right? And this is the port you want to specify. So that's that. Once we specify all of these information, we will get a new executable called shell.exe, and once we move this to the target machine and execute this, we will get the reverse shell. Now here we have stage versus stageless payloads, different types of payload. The way we had the shells, like reverse shell and bind shell. Okay, I'm gonna explain this using this guide. So this is the, let me, so this is the stage versus stageless. A stageless payload is like, let's understand from the analogy. When we order pizza, we get the already made pizza. So the stageless payload is something like that. We get the complete package, we get the complete executable. All the shell code is in the .exe. The file is bigger, the size is bigger. When it runs, we immediately get the shell, and we use the netcat to catch the shell on on our attacker machine, right? So this is, we start the listening, we specify the IP and the port on the payload, in the payload, and once it get executed, we get the shell. Now this is the complete package, you can think of it like that. And this stage payload is like a pizza delivered as ingredient, then we cook it by ourselves. So first of all, we get a small shell.exe, the executable, but it does not have all of the code that it needs to give us the shell. But instead, we just specify the IP address and the port. So once it get executed the payload on the target machine, it connects back to us. Just so once it connects back to us, we send the real shell code. The file is smaller because it does not have the full code. Once it connects to us, we send the real shell code and it get executed, right? So this is good. One of the reason it is good, because the first stager, the first file, the low size file, does not have any malicious thing and does not contains any stuff that will make the antivirus to detect it. But once it connects to us, we then after that we send the real shell code, right? Now this must be called using the Metasploit multi-handler, not with the netcat. This is the same thing, like different. Netcat is like, as I said, used for to catching the shell, but this this multi-handler thing is the same. We just start listening on that guy and we catch the shell. Hey, as you said, the stage was stateless. In stateless, we get the direct shell, right? And direct reverse shell. But in staged, you said one of the small dropper or stager get executed on the target machine, it connects back to us, and we then send the real reverse shell code. Now my question is that if you look at the stage one, it still get connect back to us. So why you said we don't get the reverse shell directly, but after it get executed, we then send the code, the reverse shell code. If you look at it, if you zoom out, it still connects to us. So I have a confusion in this. Can you clarify? Okay, so I have asked the Claude that in the stage list we talk about, we just get the direct shell because the all of the code that it needs is available in the .exe file or whatever executable file we created, right? But in the stage payload we talk about, first a tiny stager runs on the target machine, it connects back to us, and we send the real shell code, and after that it get executed. Now my question was, even if we like create a small stager, tiny stager file that will get executed on the target machine, it still connect back to us. So we get some kind of connection, and after the connection we send the real code. So we kind of establish something, the connection or something that made us able to send the real shell code. Now this is what I asked. Let me see. So it made me this visual representation. Let me see. There is like overlapping, but this is the target machine. Okay, so this is a bit confusing. Let's understand from this. So in stateless file runs, the payload runs on the target machine, it connects to you, boom, we get a shell immediately. The connection is the shell delivery. Yep, this is the thing, we just get the shell directly without any other thing. Now in the stage one, we run the stager, connects back to you, and now you send the shell code, then you get the shell connection. After we send the shell code, we after that we get the shell. So it is waiting for us. The When the stager run, it connects back to us, it then waits for us to send the shell code to execute, right? Like right here you see the stage list, the connection we get from the target machine is the shell being delivered. Now in the stage one, the connection is just the first checkpoint. You still need to send the actual shell code through the connection. Okay, so you said we don't get the fully functional shell in the stage one. How do we even able to send the real shell code after we get the initial connection? Can you just kind of clarify, a bit confusing this one? Okay, so I have asked, as it said that in the stage one, the target connects to us like a first checkpoint, and after that we send the shell code. Now my question was, even if we don't have the fully functional shell, right? So how do we even send the shell code, the real shell code using the stage payload? Let's understand this. Okay, so the question was, how do you send the real shell code if you get a connection only and not a fully functional shell, reverse shell? The answer is that we don't have to do anything. The multi-handler sends it automatically. So this is the visual of that. On the we start listening on the multi-handler in the stage one. Okay, we execute the stager on the target machine, and after we execute it, it is like saying that, hey, I'm here, I'm ready, and give me the shell. It is basically talking and handshaking, sending handshake packet to the MSF stager. Like it kind of connect to this multi-handler on this specific port. So after the multi-handler recognize it, the stager, is this the right stager? It checks. The multi-handler just auto checks that this is the main functionality of the MSFvenom, and does it matches my payload. After checking if this is true, it then send the real shell code, and after that the stager receive the code and injects into the memory, and now we have the fully functional shell, right? So this is that. Now let's move into, yep, this is the naming convention. Like, how do we even create the MSFvenom payload? So first of all, we specify the operating system, then the main architecture, and then specify what kind of payload we want to get. So one of the example is for the stageless is that give us the fully functional shell. This is the operating system, this is the architecture, and this is the type of shell we want to get. Stageless reverse shell, and this guy here is the stageless interpreter Linux 64-bit. This is another kind of shell. In the stage 1, this is for the Windows operating system, Windows x64 shell reverse TCP, and this is another kind of shell, stage shell, and this is for system 32, these 32-bit architecture. This is like that. So just remember this pattern: operating system, and then the architecture, and then the type of the payload. Now if you want to, we just know the operating system already, also the architecture, but now it's about the payload. To find out the right payload, we just need to type the MSFvenom dash list payloads. So we will get a lot of payloads, but we need to look ahead and see based on the requirement what kind of shell we need, right? So this is the real example of creating a shell for the Windows, and this is for the Linux. So first of all, we use the MSFvenom tool, then -p specify the executable type, the type of payload we want to get. Here we specify the pattern, the payload pattern, operating system, architecture, shell type, and then specified that we want to get the .exe file executable, and then the file will name as shell.exe. We specify the our attacker IP, attacker machine's IP, and the local port as well we want to get connection on. And this is the same thing but for Linux, right? You see right here we have different kind of the extension right here. Now this is for the MSFvenom. Hope you understood this. We simply use it for to create a advanced kind of payloads, and we talk about the stage versus stageless. Hope you also understood this. Now let's talk about the Metasploit multi-handler. We have talked about this a little bit in this, but let's talk about in this. You generate a stage payload. Now what catches it? A stage payload will not work with a plain Netcat listener. It needs something that can receive the first stage and send the second stage back. That's exactly what Metasploit multi-handler does. So this is the stage 1 that we have talked about over here, that we were confused at. Like we get the connection of, like, we execute the tiny stager on the target machine, it connects to our machine, it connects to the multi-handler, and the multi-handler check if this is the right guy, the right payload, the right stager. After checking it and verification, it then sends the rest of the code to get the functional shell. So this is handled by this guy. So multi-handler is a module inside Metasploit whose entire job is catching shells. It's a thing that listens, handles the staging process, and gives you a proper session to work. Think of it like difference between picking up a call on a basic phone, which is Netcat, versus using a sender with routing, recording, and features, which is multi-handler. The Netcat is a basic one, and this is a bit more advanced version, right? So this is the whole thing, the whole process to create a Metasploit payload. One is the first we have the -q flag, which means, and skip the Metasploit, the multi-handler banner, which like a cool text kind of thing. Skip that and clean start. Okay, so we use the sudo and then the tool name and then -q. After that, we specify select the handler module. This tells Metasploit you want to receive a shell, not exploit anything. We use the multi-handler. Multi-handler is the thing that will handle the stager and send the next code after it gets the connection. Now set the payload to match the MSFvenom. Critical, this must match what you generated with MSFvenom. Same payload, them exactly. Now after typing this, we will get over here, and after that we will type the same thing that we type that we created the same payload over here with the MSFvenom. Okay, so this is the file that will be sent over there, and this is the same thing as you said as we talk about this must match what you generated with MSFvenom, same payload name exactly. So this will be there. It's like getting information from us, and then it says enter the connection detail. We specify our attacker machine IP and then specify the port, and then the exploit -j is runs it as a background job. When shell arrives, we will see a notification. So yep, when I shall receive command shell session 1 opened, so we will get something like that. Once we see that, after typing the session 1, because it says session 1, after typing this we will get the fully functional shell. Okay, now this is all about the payload that get executed on the machine by itself by the user. Now if we cannot upload that executable on the target, we can we can do the same but with the web server. This is actually very common. Web server run codes PHP, ASP, these are different extension Python. If you cannot upload a script to them, the script can execute system commands. That's a web shell, like uploading a malicious script to a web server that get executed, and we can use that to run the commands. Okay, so that is called the web shell. Okay, so let me tell you this. Simply I have made this. I have asked the Claude that how do we in the first place even upload the, let's say we created the malicious script, okay, that we want to upload to the web server. So this is because of, let me move a bit, and you see there are multiple upload forms on a website, like profile picture upload, this guy upload, document upload, and many other upload forms. So because of this, sometimes the developer don't validate any of these perfectly with proper checking. Because of this flaw, we can upload our malicious script, and without it being checked carefully, it just like this example you see right here, you upload shell.php, okay, and we pretend that it is a picture because of the insecure file upload form, right? So the server thinks that this is image and it saves it to the upload slash shell.php. Now we know this full path. So what we do is target.com, this is the website, this is the another path, the uploads, and then here is our shell.php. Now after that we will just type the commands that we want to get execute on the web shell. So let's say we want to check who am I, we will just type the question mark cmd equal to who am I. This will be the same, just the command will change. Okay, so after that we will see the result on the screen. Yep, my the username is this guy, or whatever the username is. So simply this is that. Now I have told you that we will talk about these Netcat. As you already know, we use it to start listening and get the connection. Okay, stage list 1, and this is it. The problem with this is if you type mistakenly the control C, it will stop the entire connection. You will have to get that connection out, and there are some other problems with it as well. So there are good ways, better ways to fix this. One is the Python has a built-in module called PTY. This gives us the fully functional shell even if you these problems are being fixed in this, right? So one way to use the Python to get the perfect shell. Another is this guy RLwrap, and other are socket. Socket is good as well. But even if you type the control C and those problems that the normal Netcat shell has, it is a perfect. It does not have these flaws, right? So these are, I'm just gonna tell you these like overview, just so you don't, just so you know that yep, there are other ways to get the more reliable shell. Socket, the Python, and this RLwrap thing. And then the encryption is that if you want to hide the if you want to get the shell, but if you don't want to see the full traffic, you can encrypt the traffic as well using the OpenSSL and these other tools as well. So this will kind of encrypt your uh, communication, and nobody will be able to see that, right? So hope you understood all of these. We have talked about in the previous video about this, and the recent video that I upload, I talk about this. And now in this video we have talked about this guy, this, and just give the overview about these. Hope you understood these. If you have any question, let me know in the comments. Okay, and I will see you in the next video. See you soon.